There are two categories of the welding processes: the fusion welding and the solid-state welding. The arc welding process is a fusion welding process in which the merging of the metals is achieved by the heat from an electrical arc between the electrode and the work. The electrical energy from the arc produces a temperature up to 10,000 Fahrenheit or 5,500 centigrade, which is hot enough to melt any metal. Add filler metal to increase the volume and the strength of the weld joint. The electrical arc is a discharge of the electrical current across a gap in the circuit. The ionized columns of the gas, which is known as plasma, through which the current is flow. The arc welding electrodes can be classified into consumable and non-consumable. The consumable is going to consume during the welding process and is a source of the filler metal in the arc welding. The forms of the consumable electrodes are going to be in the form of the welding rods or the weld wire. Non-consumable is not consumed during the welding process. The filler metal must be added separately if it's needed. It's made of tungsten, which resists the melting, but it's going to be gradually debilitated during the welding process. At high temperature in the arc welding, the metal is chemically reactive to the oxygen, nitrogen, and hydrogen in the air. To protect the operation, the arc must be shielded from the surrounding air in arc welding processes. The arc shielding is accomplished by either using the shielding gases like the argon or the helium or the carbon dioxide, or by using the flux. The flux is a substance that prevents the formation of the oxides and other contaminants in the welding, or dissolves them and facilitates the removal. The flux provides a protective atmosphere for the welding, stabilizes the arc, and reduces spattering. The various flux application methods are the pouring of the granular flux onto the welding operation, or the stick electrode coated with the flux material that's melted during the welding to cover the operation, or using the tabular electrodes in which the flux is going to be contained in the core and released as the electrode is consumed. The gas metal arc welding uses a consumable bare metal wire as an electrode with a shielding by a flooding of the arc with the gas. The shielding gases include the argon and the helium for the aluminum welding and the CO2 for the steel welding. The gas metal arc welding has a better arc time because of the continuous wire electrode feeding, and has a better use of the electrode filler metals than the SMW. The higher deposition rate and eliminate the problem of the slag removal and can be readily automated. The flux-cored arc welding is an adoption of the shielded metal arc welding to overcome the limitation of the stick electrodes and has two versions. The first one is a self-shielded flux-cored arc welding, where the core includes the compounds that produce shielding gases. The second type is the gas-shielded flux-cored arc welding, by using externally applied shielding gases. The electrodes is a continuous consumable tubing containing a flux and other ingredients in its core. Presence or absence of externally supplied shielding gases distinguish first the self-shielded core provide the ingredients for the shielding, or the gas shielded which use external shielding gases. The submerged arc welding uses a continuous, consumable bare wire electrode with arc shielding by a cover of a granule flux. The electrode wire is fed automatically from a coil. Flux is introduced to the joint slightly ahead of the arc by gravity from a hoover. Completely submerged operation, preventing the sparks, spatter, and radiation. The gas tungsten arc welding, or known as a TIG, uses a non-consumable tungsten electrode and an inert gas for the arc shielding. This can be used with or without a filament metal. When the filament metal is used, it is added to weld a pool from a separate rod or wire. The main applications are for the aluminum and stainless steel mostly. The advantage of the TIG is the high quality welds for the suitable applications. No spatters, because no filament metal through the arc. Little or no post-weld cleaning because of no flux. The disadvantage is generally slower and more costly than the consumable electrode arc welding processes. The plasma arc welding is a special form of the gas tungsten arc welding in which a constructed plasma arc is directed at the weld area. Tungsten electrode is contained in a nozzle that focuses a high-velocity stream of the inert gas into the arc region to form a high-velocity, intensely hot plasma arc stream. The temperature in the plasma arc welding can reach 28,000 degrees. The advantages of the plasma arc welding are the good arc stability and the excellent weld quality. It has better penetration control than the other arc welding processes, high trouble speed, and can be used to weld almost any metals. The disadvantages are the high equipment cost and also the large torch size other than the other arc welding processes, and this will tend to restrict the access to some joints. The resistant welding is a group of fusion welding processes that uses a combination of the heat and the pressure to accomplish the coalescence. The heat generated by the electrical resistance to the current flow at the junctions to be welded. The principal resistance welding process is the resistance spot welding. A resistance projection welding. The resistance welding process in which the coalescence occurs at one or more small contact points on the parts. The contact points are determined by the design of the parts to be joined. Other resistance projection welding operations are the welding of the fasteners on the sheet metal and the cross-wire welding. Other fusion welding processes are fusion welding processes that cannot be classified as an arc, resistance, or the fuel weldings. They use a unique technologies to develop the heat for the melting. The applications are typically unique. The processes include the electron beam welding, the laser beam welding, electroslag weldings, and the thermal welding. The electron beam welding is a fusion welding process in which the heat for the welding is provided by a highly focused, high intensity stream of the electrons striking the work surface. The electron beam welding gun operates at a high voltage to accelerate the electrons. The beam currents are low, and the power in the electron beam welding is not exceptional, but the power intensity is very high. When first developed, the electron beam welding had to be carried out in a vacuum chamber to minimize the disruptions of the electron's beam by the air molecules. The pump down time can take as long as 1 hour. Accordingly, there are three vacuum levels in the electron beam weldings. The half vacuum weldings, medium vacuum welding, and the non-vacuum welding. The electron beam welding can provide a high-quality welds, deep and narrow profiles, with limited heat effective zone and low thermal distortion. No flux or shield gases are needed. However, the disadvantage of the electron beam welding is the high equipment cost, the precious joints preparations and the alignments required, and the vacuum chamber required. The most important disadvantage is the safety concern. as the electron beam weldings generate the X-rays. Laser beam welding is a fusion welding process in which the coalescence is going to be achieved by the energy of the high concentrated, coherent light beam focused on the joint. Laser beam welding is normally performed with the shielding gases to prevent the oxidation. The film metal not usually added. High power density in a small area, so the laser beam welding often used for small parts. No vacuum chamber is required for the laser beam weldings, no X-ray emitted in the laser beam weldings, and the laser beam can be focused and directed by optical lenses and mirrors. Laser beam weldings not capable of a deep welds and high depth to width ratios available in the electron beam weldings.